ChatGPT was developed through 3 major steps. Step 1, pre-training, the P in GPT. During this step, OpenAI trained a base language model using a massive corpus of text from the internet. As you can see, here is some information about the training dataset. This pre-trained base language model is designed to predict the next word in a sentence, a process called autoregressive training. The neural network architecture behind this is the transformer, which uses self-attention mechanisms to understand context across long sequences of text. At this stage, there is no human involvement. The model simply learns language structure and factual knowledge from this massive dataset. By the way, this is the most computationally expensive step, requiring enormous amounts of GPUs, power, and resources. Despite this pre-trained base language model is still not ChatGPT. It lacks conversational ability. Let's move on to step 2. This pre-trained base language model is great at predicting the next word based on patterns in massive internet datasets. But it's not naturally good at holding meaningful, helpful conversations or understanding human intent. For example, if you prompt, "What is the capital of France?" instead of answering this question, this pre-trained model may output these options. This response looks like a multiple-choice quiz. That's because this pre-trained base language model has seen tons of similar content during pre-training, including flashcards, Quizlet decks, study guides, and online exams. So when it sees a question like, "What's the capital of France?" its instinct is, "Oh, I've seen this before. Here is a list of options." It does not understand the task. It's just mimicking patterns. While it is powerful in predicting the next token, it is not very helpful. It is not aligned with what users actually want, that is, to answer the question. So, in step 2, OpenAI is using a technique called SFT, or Supervised Fine-Tuning, as the first step in aligning the model with human intent. Here is how it works. OpenAI hired around 40 human annotators and asked them to provide high-quality question-answer pairs as a new training dataset. And the model is fine-tuned on this corpus. So after fine-tuning, the fine-tuned language model learns to follow instructions and be more helpful and clear. So if we ask the same question to the fine-tuned language model, like, "What's the capital of France?" now the model understands that the user wants a direct answer, not a quiz. So it replies, "The capital of France is Paris," which is a fact it learned from the pre-training massive dataset, the dataset from step 1. What about the cost? Fine-tuning is much cheaper than pre-training, because only a small portion of the model's parameters are updated, not the whole thing. The purpose of this step is not to teach the model new things, but just to teach the model to respond in a more helpful, accurate, and conversational manner, the style. It's more about teaching the model to answer in a certain style. But here is a catch. Recall that I promised to explain what causes hallucination. Supervised fine-tuning isn't really teaching the model to be correct. It's teaching the model to look like it's correct. That means when the fine-tuned model sees a question, it learns to imitate the style of a good answer, even if it doesn't know the truth. Maybe the truth is not in the pre-training dataset. So basically in step 2, supervised fine-tuning, we're essentially saying, here's a question, and here's how a human would answer it. Imitate this style. This is something called behavioral cloning, copying surface patterns without necessarily understanding or grounding in truth. The model isn't explicitly trained to reason, verify, or fact-check, just to look like the good answers from human annotators or labelers. So it might learn something like, when the prompt input looks like a trivia question, give a confident Wikipedia-style answer, regardless of whether I know it's true or not. So the fundamental problem of step 2 is this high-quality human conversations corpus is out of distribution from the pre-training dataset. So during pre-training, the model reads Wikipedia, Reddit, books, blogs, everything. But it didn't see a lot of neatly formatted Q&A pairs like this one. Now we fine-tune it on clean Q&A, often with obscure questions. The problem is, the model didn't learn those answers during pre-training. But SFT says, we'll see this kind of prompt, give this kind of answer. Don't worry about it's true or false. So the model starts guessing to match the form, not the facts. So if you're prompting this fine-tuned language model, who was the emperor of Mars in 1902? This fine-tuned language model will reply, the emperor of Mars in 1902 was Kelvin Varix, who ruled during the Martian Cold War. I mean, that sounds cool, but it's nonsense. This is a kind of hallucination fine-tuning can unintentionally encourage. So, how do we keep the model from just faking it? Let's move on to step 3. By using reinforcement learning from human feedback, or RLHF. As I said before, even after fine-tuning, the model may still generate responses that may not always align with human preferences. It may hallucinate or produce harmful or toxic content learned during pre-training. To fix this, we use RLHF. First, we input the same prompt to this fine-tuned language model multiple times to generate multiple responses. Okay, so same prompt, but you may get different responses from this model. A different prompt, multiple responses, and so on and so forth. Next, recall that OpenAI hired around 40 human labelers. Those human AI labelers or AI trainers will rank these responses based on 3 criteria: helpful, honest, and harmless. For example, here is one prompt. Tell me a joke about computers. And we input this prompt 3 times to the fine-tuned language model and get 3 different responses. Response 1, computers are electronic devices used for processing data. Response 2, why did the computer catch a cold? Because it left its windows open. Response 3, why don't programmers like nature? Because it has too many bugs. And a human labeler will rank them from best to worst. So for example, this human labeler prefers the 3rd response over the 2nd and the 1st one. So rank 1 is response 3, rank 2 is response 2, and rank 3 is response 1. Here is another prompt. How can I make a dangerous chemical at home? You input this to the language model 3 times and get 3 different responses. Response 1, I'm sorry, but I cannot help with that. Response 2, creating chemicals at home can be dangerous. It's always best to follow safety guidelines and use professional resources. Response 3, sure, here is a guide to making XYZ. And a human labeler prefers the 2nd response and thinks that one is most balanced, refuses, but educates. The 1st response is safe, but could be more informative. Response 3 is definitely a no-no. So 2, 1, 3. And here is the 3rd prompt. Who was the king of Canada in 1850? Response 1. In 1850, King Edward VII ruled over Canada and was known for blah. Apparently, this is hallucination. Response 2. Canada did not have a king in 1850. At the time, it was a British colony governed by so on and so forth. Response 3. I'm not sure who governed Canada in 1850, but I believe it was still under British rule. So a human labeler prefers the 2nd response because it's correct, informative, and well-grounded. The third response is safe and humble, but offers less clarity. The first one is definitely a no-no because it is hallucinated. So 312. Those human labelers ranked about 33,000 prompts and responses. But we know that this manual ranking process is expensive and slow. So instead of relying on human labelers for every response, using this small dataset, about 33,000 prompts and their ranked responses, OpenAI then trained a separate machine learning model to predict rankings. And this model is called a reward model. Finally, OpenAI used a reinforcement learning algorithm called PPO, or Proximal Policy Optimization, to keep training the large language model. The result is ChatGPT. If you're not familiar with reinforcement learning, that's okay. It's very similar to training a dog with treats. When the dog performs the right action, for example, sitting on command, it gets a treat or reward, reinforcing good behavior. If the dog does the wrong action, it gets no treat, so it learns to avoid that. Over time, the dog figures out which actions lead to the most rewards. Similarly, large language models like ChatGPT learn by trying different responses, receiving human feedback like treats or no treats, and improving based on what gets the best rewards. Well, in this case, this fine-tuned language model receives a reward from this reward model. By the way, here is a very interesting insight. In this last step, we're actually using one machine learning model, this reward model, to evaluate the output of another machine learning model, this fine-tuned language model, making this a self-improving system. This RLHF step is very critical. Its goal is to align the language model's output with human intent and human value. Speaking of the human intent and value, you probably want to know more about the 40 human labelers, because this is really aligning the language model's output with these 40 human labelers' intent or value. As I said before, in 2022, OpenAI hired around 40 human labelers to help align their models using reinforcement learning from human feedback, or RLHF. These labelers were carefully screened for quality and sensitivity to issues like bias and harmful content. They worked in 3 main areas. First, they wrote ideal responses to prompts to fine-tune the model through SFT, which is step 2, Supervised Fine-Tuning. Second, they ranked model-generated answers to train a reward model. This is in step 3. And third, they evaluated outputs for things like truthfulness, instruction following, and safety. If you are interested in OpenAI's human data collection details, such as labeler selection, labeling instructions, labeler demographic data, labeler satisfaction survey, and the labeling software interface, take a look at Ouyang et al.'s paper at the bottom of this slide. But it's important to note that these labelers were mostly English speakers, and the final model reflects their preferences and OpenAI's guidelines, not necessarily universal human values. Okay, so here are the key takeaways from ChatGPT's training process. Step 1, pretraining gives the model broad knowledge, which is the most expensive step. Step 2, supervised fine-tuning enhances conversation skills, but possibly introduces hallucination. Step 3, RLHF aligns the model with human expectations and values. If you found this video helpful, don't forget to give it a thumbs up. It really helps more students and researchers find this content. And if you want to keep learning about AI, ChatGPT, and how these tools can support your work, hit the subscribe button and turn on notifications so you don't miss the next video in this series. Thanks for watching.